We are starting TK Academy. TK stands for Team Knowledge for Architects and Designers. This is a core competency course, which is the basic knowledge all architects and designers should have. And today we are covering the topic of specifications. Our learning objectives: once you complete this course, you will be able to do the following. Identify the different types of specifications that can be used on a project. Recite the three parts of the standard framework of specification sections. Explain the differences between general conditions and general requirements. Explain the differences in the type of design information that is included in specifications and that which is included in construction drawings. So why should a project include specifications? Why can't they just simply use the drawings? The purpose of specifications is to convey in writing what the design intent is to the contractor who is responsible for bidding and constructing the project. The written word is more universally understood, and therefore specifications typically take precedence over drawings on a project. Specifications form part of the legally binding contract documents between the owner and the contractor, as well as the drawings do. Specifications define quality, methods, and techniques of installation. They also indicate color, texture, finishes, and performance of materials and systems. These are items that are more easily explained in written word than they are by drawing. There are different types or methods of writing specifications. They are proprietary, performance, reference, descriptive, and cash allowance. The proprietary specification method involves including specific products and manufacturers identified as meeting the design intent and are available for the contractor to use on a project. This method relies on the detail and accuracy of the literature produced by the manufacturer. It is relatively easy to prepare compared to other specification methods, and therefore is the most typical and common type used. There are two kinds of proprietary specifications: open and closed. The first type is an open specification, or what we call an equal specification. It is where the specifier will list several acceptable manufacturer products from a pre-approved list, typically at least 3, but there can be many more than that. The contractor may use any of those systems to satisfy the project requirements. A product of equal quality or performance may be substituted if prior approval is received from the architect or designer. This really comes into play during the bidding of a project. If an open spec is used and a particular product or manufacturer is not listed, the contractor may submit a substitution request requesting that their representative product be accepted into the project, and then the architect or designer will either accept or reject that and issue that by addenda. This method is the most commonly used method on publicly funded projects where the government does not want to be seen as showing biased favoritism toward any one manufacturer. They want to open it up some to allow for competition, but also be able to control the quality of products and manufacturers that are going into the project. A closed type of specification is also called a sole source. This requires that one particular manufacturer or product or brand is used on the project and does not allow for any substitutions to occur. This is used when there's only one specific product that will work for the project. It is usually a proprietary system that was custom developed for this specific application, and the design has been developed around that, and so that is the one system that is going to be used on the project. It does not allow for competition. And that is the downside of using a closed or sole source. It is a very easy spec to write, but you do not get competition, and therefore you are usually subject to the highest price on your bid. That is the reason why it's typically not used on publicly funded projects. A sole source is more common on private projects. And here's an example of an open proprietary spec. We're not going to worry about this on the top, but we're going to take a look down here in part 2 for products and look at this as an example. So you can see here that underneath manufacturers, there are several different manufacturers that are listed in each category. For example, we have hinges here. There are at least 3 different manufacturers that are listed underneath hinges. And then also a phrase that says here, any manufacturer of products comparable in performance and quality. So what this statement says is that the contractor can provide anything that is of equal of quality to these 3 different manufacturers. It does not need to get prior approval. This next example for lock and latch sets, again, this lists 3 different systems, manufacturers that may be used. But then here, this clause says a little bit different. This is substitutions, and it refers to another section of the specs. So this says if you want to use anything besides this, you have to do a substitution request before and get prior approval. And here's an example of a closed proprietary specification. Again, we're going to skip part 1. We're going to look at part 2 here, products and manufacturers. And so you can see from this, it's a very short section, and it lists underneath manufacturers, it lists just one manufacturer, and then it even goes in as far as dealing with the model. It tells you not only the manufacturer, but what product to use. And then underneath here it says substitutions not permitted. So this spec says this is the one system we're going to use and the only one we're going to accept. We're not going to allow for any type of substitution. Just skipping down here to part 3, which is the execution, and I highlighted and bolded this. I'm going to highlight in green here too. It says install according to the manufacturer's instructions. So this is why a closed proprietary spec is so easy to write. You don't have to list multiple things in the product section. You can just list one specific manufacturer and model, and installation you can really just default to the manufacturer's installation instructions. The next type is a performance specification. This type of specification defines products by describing the desired or end result in the performance. So essentially it is saying that we don't know what it is, but we know what we want it to do. This type of spec is often used with design, build, delivery methods. It allows a contractor or manufacturer to be creative, apply their individual expertise and experience, and encourages innovation and competition in the market. In order to write this type of specification, you must define the criteria and required testing methods in order to evaluate and rate the performance. That makes it one of the more difficult and challenging type of specifications to prepare. This type of specification is most appropriate for when you are using a new or unusual product. And here's an example of a performance specification. For this particular example, we are going to use asphalt paving, which is very commonly written as a performance spec. Underneath part 1 in paragraph 1.03, here we have the performance requirements. Here's where we list what the criteria needs to be, how it needs to perform. So the first sentence says, design paving and subspace at drives for movement of trucks up to 30,000 pounds. So that is the criteria that they need to design this asphalt paving mix and system in order to support this movement of these trucks, 30,000 pound trucks. The next criteria, the performance requirements, is design paving and subspace at parking for light-duty commercial vehicle traffic. And we assume that the contractor knows what that means, what the performance needs to be for light-duty commercial vehicle traffic based upon the type of vehicles, the weight, and the amount of turning and wear and tear that's going to be on that surface. So essentially this is a delegation of design. We're not giving them design information, we're telling them what the criteria is, what the performance needs to be, and telling the contractor to design a system that will meet that performance. Then down in part 2, we have a section here, asphalt paving mixes and mix designs. And we're telling the contractor to submit proposed mix design for each class of mix for review prior to the beginning of work. So we told them up here in part 1 that they need to design the system for this type of performance, and now we want them to submit this proposed mix design for the designer for review before they begin work. Next paragraph, source quality control, says test mix designs and samples in accordance with AIMS2. So we gave them the criteria, now we're going to tell them the means of which that performance is going to be tested and evaluated by. Next is reference specifications. A reference specification defines products by the quality standard established by recognized testing authorities within the industry. ANSI, ASTM, and UL are some common examples of testing authorities that develop quality standards. A reference specification typically does not stand alone. It is usually used in conjunction with other types of specifications, such as a performance spec. The reference standard usually indicates a minimum quality standard, and so it may not always be sufficient for what the desired result is. Sometimes the minimum is not enough. You want to go above and beyond. Most cases, the minimum quality standard is sufficient. Reference specifications must be constantly updated with the most current quality standards. So the testing authorities are continually to test new products, test new systems, develop new standards, and so these quality standards are constantly changing. And so unless you prescribe to a certain type of system that stays on top of these changes, it can be very difficult to maintain the reference specifications with the applicable quality standards in the industry. This is an example of a reference specification. This one is pertaining to hollow metal doors and frames. And so right here at the beginning, you'll see that we have listed several applicable reference standards for this project and what those reference standards are. So here's NFPA, that one's very familiar, UL, Underwriters Laboratory. So all the applicable standards are listed here. And then for each system or for each part, for example here, delivery, storage, and protection, store in accordance to NAAMM HMMA 840. So we don't tell the contractor what to do in this case. We say to do it according to this standard. And so the contractor has to go back and look to see what this standard is up here to know what was the appropriate action to do here with storing these products on site. For part 2 in the products, here we list steel doors, STC rating of assembled door frame and seals. We give them what the STC rating 35, calculated in accordance with ASTM E413. So that's how the standard that the reference standard that it's going to be tested by. So it's a little bit of a performance spec here too. And then tested in accordance to ASTM E90 or ASTM E1408. Okay, so again, reference standards says that it needs to meet this requirement according to these different standards, testing standards. Even in the execution and installation, we tell the contractor that they will install this in the requirements according to, and then list a certain reference. So pretty much everything that we are telling the contractor to do in this, in part 1, how they are supposed to receive, store, ship, handle these products, what the products are, how the performance of them, how they're going to be installed, all that is simply citing another reference standard, and the reference standard tells them the specifics on what needs to be done. Descriptive specifications defines products or systems by describing all the components of it, the arrangement and methods of assembly, the physical or chemical properties, relationships to other parts and pieces, and other numerous details and requirements. In writing a descriptive specification, the architect or designer assumes responsibility for that product's performance and function. From this definition, one could understand how descriptive specifications can get very long and very wordy. They can be the most difficult and challenging type of specification to prepare. Therefore, it is one of the least used type of specifications. In descriptive specifications, it is often the case of where less is more. Putting less information in your specification works to your advantage because of the time and energy it takes to prepare that information and the open liability that one has for including it in your project requirements. In the case of many model specifications where one is working with a guide spec that is all inclusive and it is edited by removing content that is not applicable, when there is a certain content that the editor is not sure of, what is intended or if it's required, it's always best to not include that in your specification because of the open liability that the designer may carry for requiring something in the project that the editor is not sure of. This is an example of a descriptive specification. Looking underneath Part 2, you can see that we have a paragraph here that talks about the components, in this case for a window. We have a paragraph about materials, and we have a paragraph about fabrication, and this list can continue on and on. Underneath components, we identify the parts of components, the windows, the frames, the sills, and even the fasteners. Underneath materials, we call out the different materials that are part of this, the wood and the metal cladding. And then, I'm not going to go through each one of these, but you can see the long, lengthy description here of what each one of these components. We have on frames here, it's called out the size. It's talking about how the material must match the fastening type. It's got to be sloped for wash. Here again, it indicates the size of the sills and fits underneath the sash to project 1/2 inch beyond the wall face. So you can see this gets very, very descriptive to where we are really dictating how this is assembled and put together. The wood, we're getting into very detail what type of species of wood, what type of treatment, what type of finish it's going to receive, metal cladding, same type of thing here. Gets into a lot of detail, which again takes a lot of information to put this together. But again, when you are dictating this level of detail, you are assuming a lot of the responsibility and liability of the performance of this product or system. The final type of specification is called a cash allowance specification. A cash allowance specification does not indicate a type of product or system, but what it does is directs the contractor to set aside a specified amount of money to be applied during the construction work at the architect's or owner's discretion. This type of specification is used when full information regarding a product or a portion of the work is not yet determined at the time of bidding. The cash allowance may be used for purchase and delivery. The installation cost of a material or system should be indicated in the construction documents and is usually part of the base bid. This is commonly used on finishing items such as carpet or door hardware. Another example where this is used quite a bit is in remediation or repair to damaged work that is not yet known because it is currently concealed within the existing construction. Flooring, if the flooring is going to be replaced, we know that the concrete slab may be old and worn, cracked, may need some patching or leveling, but we don't know the extent of that until the existing flooring is removed. Therefore, we would use a cash allowance, set aside that certain amount of money for the purpose of patching and repairing of the floor before the new floor system is installed. Here's an example of a cash allowance specification. In this case, it is for tile carpeting. So flooring often is done as a cash allowance specification. Paragraph 1.02 cash allowance. So this includes what indicates what costs are included and what costs are not included in this cash allowance. So the cost included is the cost to basically for the material, to procure the material. Costs that are not included, delivery to the site and handling the materials at the site, protection of the product from the elements, so storage, and then labor for installation and finishing, because they probably have already indicated on the drawings what the extent of carpeting is. We just don't know what the material is yet for pricing. Here's another way of doing a cash allowance. This is for contingency. And so it's always wise to carry a contingency amount in a project. In this case, the owner is not keeping the contingency. We are putting it on the general contractor. We're telling the general contractor that they must carry a contingency for the project. And this probably should have some type of sum in here telling them what amount of contingency to carry. But then this is available for the owner to be able to draw on this. So when unexpected things do come up on the project, the general contractor has that contingency allowance already there and then it is executed by change order and drawn down from that allowance amount. Important thing to know on a contingency allowance like this is any remaining amount that is not used is given back to the owner. This is not something that the general contractor gets to keep. It goes back to the owner if it's not used. Important part of a cash allowance specification is this allowance schedule. So this tells the contractor how much money to include in their bid, in their cash allowance amount, and for what. So here we have this example: $2,000 for removal of existing floor material, $1,500 for subfloor repair and preparation. And this is a very good example of how to use a cash allowance specification. We know that there may be some repair and remediation work that needs to be done to the subfloor or substrate, but we don't know the extent of that because it's currently covered up with the existing floor. So we won't know it until we remove the floor, and then we can evaluate and see how much repair and work needs to be done. And that money is there to execute that work, and the contractor can draw down from that. Again, any remaining amount that's not used, if there's not much repair work, that then goes back to the owner. And then the final amount here, $4,000 for purchase, delivery, and installation of a 24 by 24 carpet tile. This is sometimes the case where we just haven't selected what the final carpet is going to be. There may be 3 or 4 different options, and the owner hasn't decided, but the project has to bid. So we just put this contingency in there, and then we know it's not going to be more than that. So once the decision is made on the type of carpet, then they can go ahead and purchase and procure it and install it for that amount. Now that we've described the 5 different types of specifications, we're going to get into the standard framework that is used on specs. Specifications are typically written in outline form using different levels. Each successive level describes greater detail of the product or system. So the first level, level 1, is division. Level 2 is section. Level 3 is referred to as a part. Level 4 is a paragraph. Level 5, subparagraph. And level 6 is a sentence. The first 3 levels, divisions, sections, and parts, form part of the permanent framework for specifications. Divisions being the highest level, they have a fixed name and number and cannot be changed by the specification editor. Sections, the next level, describe the basic unit of work within the division. The section name and number can vary depending upon the type of work it describes, but most fit within a predefined designation. After divisions and sections, the next level is parts. Each section will have 3 parts: general information, materials, products, and execution. Part 1, general information, will describe related work, definitions, quality control, submittals, and warranties. Part 2, materials, lists products, manufacturers, and equipment used. Part 3, execution, describes the way the work is performed and the method in which products are installed. Most project specifications will follow the CSI's standard formats. CSI is the Construction Specifications Institute. It is the organization that is primarily responsible for establishing industry standards for specifications. Specifications that are written in outline form typically follow the CSI standard format. It is the most widely used and most commonly accepted method used across the United States. The system that CSI uses to organize specifications is referred to as master format. For a good portion of history, master format organized specifications into 16 divisions. However, the last time the 16 division standard was used was in the 1995 master format version. The 1995 master format version used a 5-digit numbering system to organize specifications. The first 2 digits indicated what division or level 1 detail. For example, 08, which is division 8, would indicate doors and windows. Each of the next 3 digits is taken individually to represent the next levels of detail, levels 2, 3, and 4 respectively. So in this example, we have division 08, doors and windows. 5 would indicate the next level, windows. 2 What type of windows? Aluminum windows. And 5 would indicate architectural grade aluminum windows. These numbers are written together without spaces to indicate a specification section. So a specification section 08525 would be aluminum architectural windows. Most people think of CSI being a crime scene investigation from the popular TV show, and one would have thought there actually was a crime scene when CSI announced that it was switching from the 1995 master format version to the 2004 master format version. This was a significant change in the industry, and it was very difficult for many to adapt to. The 1995 master format had 16 divisions. 2004 master format version expanded this to 49 divisions. The 1995 master format system used a 5-digit numbering system. 2004 master format system expanded this to a 6-digit numbering system. In addition, divisions were now categorized into groups: the Facilities Construction Group, Facilities Services Group, Facilities Site Group, and Process Equipment Group. So why did CSI make this change? In the 16-division system, there were many divisions that were very confined, such as mechanical and electrical, and they could not accommodate the future growth and advancement within the industry. Certain things such as information technology, which was becoming very prevalent within the industry, had no place to be categorized. And so they had to expand the system to allow for growth. When they made this change, they did accommodate for future growth by also creating reserve divisions. The 2004 master format version and subsequent follow-on versions made the following changes from the 1995 and previous versions. Divisions 0, 1, and 3 through 14 remained the same. Division 2 changed from site work to existing conditions. Division 15, mechanical, was expanded and subdivided into 5 different divisions. Same with electrical. Division 16 was also expanded and subdivided into 5 divisions. Division 2, site work, was moved into its own category and expanded into 10 divisions. Process equipment category was added with 10 divisions. Also new to the 2004 master format version and subsequent follow-on versions was the introduction of groups and subgroups. Specifications were really in 2 groups, the first being procurement and contracting group, and the second being the technical specifications group. Within each group there were subgroups. In a procurement and contracting group, the subgroup was simply Division 0, procurement and contract requirements. In the technical specifications group, there were multiple subgroups. The general requirements subgroup, which included Division 1 general requirements. The facilities construction subgroup, which included divisions 2 through 19. Facilities services subgroup, which included divisions 20 through 29. Facilities infrastructure group included divisions 30 through 39, and the process equipment subgroup included divisions 40 through 49. The facilities construction subgroup, which included divisions 2 through 19, was very similar to previous versions. Again, division 2 was changed to existing conditions. 3 through 14 remained the same with just some minor differences. But now there was divisions 15 through 19, which were included as reserve categories for future systems. The facilities services subgroup includes divisions 20 through 29, and these are your mechanical, electrical, plumbing specifications. In previous versions, these were confined to just divisions 15 and 16, and there was not enough room to be able to accommodate all the different systems and for the expansion within the industry. This was broken out now into 10 different divisions, which gave it much more capacity for all the different systems that are included in contemporary buildings and allows for continued future growth. The facilities site subgroup, which includes divisions 30 through 39, found itself in the same position as services did in the previous versions. The site conditions were limited to Division 2, and there just was not enough room for all the different complex systems that are involved with contemporary projects. So this needed to expand. They moved facility site into its own subgroup, with 10 different divisions, with several divisions that are reserved for future expansion. Another significant change introduced in the 2004 master format version was the change from a 5-digit to a 6-digit numbering system. The concept is the same in that the digits indicate the level of detail. The first 2 digits indicate the division, or level 1 detail. In this example again, 08 indicates division 8, doors and windows. The next set of 2 digits indicate the second level. This is an increase. In the 1995 master format, it was a single digit. Now it has been expanded to 2 digits to indicate more than 9 subdivisions. In this example, 51 indicates metal windows. The final set of 2 digits indicate the level 3 detail. Again, previous versions had a single digit. The 2 digits allow for more than 9 subdivisions. In this example, 13 indicates aluminum windows. There are some cases where a level 4 pair of numbers can be added at the end. These numbers are either written together with or without spaces to indicate a specification section number. This example, 085113, is aluminum windows. The reason for this change from 5 digits to a 6-digit numbering system is that it allows for 10 times as many subjects than what the 5-digit numbering system did. Now we are going to transition and talk briefly about different specification styles. There are 3 commonly used styles, the first being military, which is used by the U.S. Army Corps of Engineers and other military agencies. Sequential numbering, where each line of a section is numbered in sequence, and the CSI style, which is the most used and commonly accepted style. This style follows the rules of standard outlines using both numbers and letters. This is an example of a military style specification where every part, paragraph, subparagraph, and sentence is numbered. Each subsequent number indicates another level of detail within the specification. So, for example, at the top here we have 1.5. 1 indicates part 1, 5 indicates the 5th paragraph of that part. In this case, it is environmental requirements. Then the subsequent subparagraph is 1.5, which is the parent number of the paragraph, and then 1, which is the first subparagraph of that paragraph environmental requirements. 1.5.2 is the second subparagraph of paragraph 1.5 environmental requirements. Let's continue on with this example. We have part 2 products, and I'm going to skip down to 2.2 mortar materials. So we have part 2, and I skipped this first paragraph to the second paragraph, so that makes it 2.2 for the second paragraph. And then we have 2.2.1, meaning the first subparagraph of that paragraph 2.2. 2.2.2 being the second subparagraph of that paragraph, and 2.2.3 and so on. This is an example of sequential numbering style used in specifications, where every part, paragraph, subparagraph, and sentence are simply numbered in numerical order as they occur. The advantage of this is that it could be very easy to reference an item. You can simply say line 36, which is colored mortar, required to match architect's colored sample. The downside of this is that it is very difficult to maintain as you are editing to make sure all your numbers are in correct sequence. The most commonly used style for specifications is the CSI style, which follows a traditional outline format with alternating numbers and letters. For this example, we see part 2 products, and then underneath that with the paragraph 2.01, that's simply in a sequential number for concrete masonry units. Now the first subparagraph underneath this paragraph is letter A for concrete block. Underneath that subparagraph we have sentences, and we revert back now to numbers 1, 2, and 3. In this example we even have subparagraphs A, and B. To cite a reference in this style, we would list the paragraph, subparagraph, and sentence. So if we want to talk about the special shapes of concrete masonry units, we would reference 2.01.A.2. Within construction documents, there are both general conditions and general requirements. These are easily confused, but they deal with very different aspects of the construction documents. The general conditions. This deals with contractual issues, so it's general conditions of the contract, not general conditions of the project. General conditions are prepared by the owner or the owner's legal representation. They are not considered part of the specifications, although they are often included in the front of a project manual. And general conditions are pretty much standardized, and they do not change much from project to project. However, on the other hand, general requirements. These deal with administrative issues of the project, not contractual issues. They are typically prepared by the architect. General requirements are in Division 1 and are considered part of the project specifications. In Project 1, general requirements can differ from project to project. Within construction documents, drawings and specifications are meant to be complementary. There's a correlation between information that is shown on the drawings and that which is included in the specifications. In drawings define the physical relationship between materials, products, and systems. Drawings indicate dimensions, sizes, and locations. Specifications, on the other hand, specifications define quality, not quantity. They define methods and techniques of installation. Specifications indicate color, texture, finishes, and performance. This is an example of a wall section and the wrong way of information being on the drawings, information that should be in the specifications, and the right way in which drawings should be labeled. So at the top here it says PVC roofing. That is very specific information. It's the type of material. The right way to be is more generic and indicate it as a single ply roofing membrane. Another example a little farther down the list, colonial red brick. We would not indicate the color on a drawing. Rather, we should just indicate it as a brick or a face brick. Same coming down here with aluminum casement window. Tells what type of window. We just need to indicate more generic information, aluminum window. Part of the reason we do this is that when we keep this information a little bit more generic, and what I like to do is use the divisions or section titles as what I label my drawings. Then if there is a change in the project, then the change can be made in one location in the specifications, and we don't have to change multiple notes on a drawing. For example, again, I'm going to use roofing. If the project was originally designed for PVC roofing and a value engineering alternative is to go with an EPDM roofing, if I labeled that the material type on the drawings, every single detail pertaining to roofing, I would have to change that keynote. But if it is kept to single membrane roofing, well, both PVC and EPDM are both single ply membranes. I could just simply change that specification section and make the change for the entire project without having to make any modifications within the drawings. Project specifications will often get combined with other documents to form the project manual. The project manual is the collection of technical information or specifications as well as other documents related to legal and procedural requirements for the project. These will include bidding documents, applicable contract forms, documents that relate to equal employment opportunity, labor wage requirements, and so on. Often the general conditions of the contract and the supplementary conditions of the contract are included in the project manual. These documents are often what was referred to as the front end of the project manual. The typical contents of the front end of the project manual consist of the following: the general conditions of the contract, which is usually the industry standard or prepared by the owner's attorney; supplementary conditions, which is a way of modifying the general conditions, is typically prepared again by the owner's attorney. Division 0, which is the procurement and contractual requirements. This often is prepared by the architect or designer. And Division 1, general requirements, which are part of the technical specifications. This is inaccurately referred to as the front end, but is actually part of the specifications. Division 1 is prepared by the architect and designer. This concludes our TK Academy course on specifications. If you enjoyed this course, please go ahead and give us a thumbs up and let us know in the comment area. Also remember to subscribe to our YouTube channel for more videos like this one and other content from TK Architecture.